it's me again. We're working on lesson 4 in unit 5, geometric series. This is adding on to what we learned in the lesson before with the summation notation, but of course it leads you to a new formula that you have to learn how to use. In the first example, we're going to review how to do the summation notation, in particular, this one that is a little bit more complicated, so you can see why we end up using the formula that we're about to use. So I notice that I'm going to start with my first term and end with my fifth term, and I'm going to add my A1 plus my A2 all the way to my A5. So I need to know what is my first term, what is my second term, and that's why I need to look at the formula that they gave me. So they're giving me my first term, but to find the rest, I need to use that recursive formula. So my recursive formula tells me that I am going to take the term before and multiply it by 2. So my A1 is 3. My A2, I'm taking my term before, multiplying it by 2, and getting 6. My third term, I'm taking my term before, multiplying it by 2, and getting 12. And I'm going to go all the way up to the fifth term. So now that I have my A1 through my A5, I am now going to do what the summation tells me to do, and I am going to add them together. And when I do that, I should get 93 as my answer. Now, what starts to happen is this is actually pretty complicated. You're dealing with the summation, but you're also dealing with the recursive where you have to keep finding the term before. So what they have come up with is a geometric series. A geometric series is basically the sum of a sequence. So it's like we were doing with the summation, but it's also a sequence. So rather than do what we did in example 1 over and over again, this formula will help us get to the final answer a little quicker. Now, what you'll see here is they are giving you two formulas. They're very similar. They'll get you the same thing, basically. In the one on the left there, if you distribute that a to the 1, it gives you that second equation. The one that I'm going to use is the one that's going to be on your reference sheet. So I'm just going to show that to you right now. Okay, so this is just a snippet from the formula sheet. What we have seen recently is the arithmetic sequence. Familiar. The geometric sequence, which is here, that should also look familiar. And then this is the geometric series that they give us. So that's the one that I'm going to keep using over and over again. Now you can use the other one, but honestly, you might as well use the one that you're going to see on the Regents, right? That makes sense to me. Example 2, which of the following represents the sum of a geometric series with 8 terms whose first term is 3 and whose common ratio is 4? So what you could do is do the summation, right? And you would do 3 plus 12, right? You would keep multiplying 4. but this gets you there quicker. So I am going to use this formula up top. I know that my first term is 3. So I'm going to plug that in. My common ratio is 4. And my n is the number of terms. And so they're nice here and they tell you that there's going to be 8 terms. So I'm going to put an 8 up there. And on the bottom, I'm doing 1 minus my ratio of 4. When you calculate that all in your calculator, be very careful. I would put the whole thing in all at once as a fraction, alpha y equals number 1, and you should get choice 4. So if I were doing that addition, summation that I mentioned in the beginning, after I added them all together, that's what I would get. This is just a quicker way of getting there. On the next page, I'm going to skip ahead to 4 because it's a little bit more similar to the one we just did, just for the sake of this being new. A person places 1 penny in a piggy bank on the first day of the month, 2 pennies on the second day, 4 pennies on the third, and so on. Will this person be a millionaire at the end of a 31-day month? So they are telling me that on the first day, they're putting 1 penny in the bank. It's up to you how you want to put this. If you want to put a 1 for 1 penny, or you can put the 0.01 for the 1 cent. No matter which way you do it, we'll end up with the same answer. So on the second day, there's 2 pennies. On the third day, there's 4 pennies. And they don't tell us anything else except that we are going all the way up to day 31. They want to know, will this person be a millionaire? They're not directly telling you that this is a geometric anything or it's a geometric series. I know it is because this is the worksheet that we're doing, but you're not going to know that on the Regents. But what I do know is that I am going to have to add all the days together. And there's 31 days. That's a lot of adding. So definitely for me, a geometric series is what makes sense. This is also geometric because how am I getting from 1 to 2 and 2 to 4? I'm multiplying by 2. So that tells me that my common ratio is 2. So that's another hint that it's a geometric. But I'm going to do a series because I want to know how much money we're going to have at the end of the 31-day months. So I'm going to use the same formula from your first page, and I am finding when my n is 31 after 31 days. So my initial term is 1, and I'm going to subtract my initial term, times it by my common ratio, which we just figured out is 2, and my n is 31. And underneath, I'm doing 1 time minus my common ratio of 2. You're going to put that whole thing in your calculator. And when you do that, I suggest you do that just to make sure you get the same number as me. Now, you're answering the question is there a millionaire? Are they a millionaire? Well, I did my chart by counting how many pennies there were. I did not do cents. So this answer is how many pennies. It's the number of pennies that we have. So the question is that $1 million? Well, how could I do that quickly? I would just move my decimal to the left twice or divide by 100. There's 100 pennies in a dollar, which is the same as moving your decimal to the left twice. So let me just clear a space here so I can write my answer legibly. All right, so it's basically the same number. I just happen to have a decimal point. And you also kind of need to know your numbers where your commas go. So I have this number. So that looks like 21 million. So yes, they will be a millionaire at the end of a month. You should do that and see how it works out for you. Exercise 5. You are offered a job that pays a salary of $51,000 in the first year and a 2% increase in each successive year. You decide to accept the job. What will your salary be during your 10th year of employment? Now, there is nothing that question A is asking that leads me to believe that it's a series like we just did. Why would we add anything together? It's only asking me what it would be in my 10th year of employment. So that part is a little tricky because it really has nothing to do with what we have been doing. Honestly, I would use a basic exponential. Remember this? So I would do y equals 51,000 times 1.02 to the power of 10. Whoa, where did that come from? Remember, A is the initial amount, and then B is 1 plus my rate or 1 minus my rate if it was subtraction. And I changed my 2% to a decimal. This is from way back in Unit 3. And then the 10 is how many years. So after 10 years, if you put that in your calculator exactly like I wrote it, their salary in the 10th year is going to be $60,949.72. Part B says you work 10 years for the company. What are your total earnings? Now, to me, that is a series because they want you to take the amount you earned in the first year, add it to the second year, add it to the third year. That's not what Part A asks you to do. In Part A, that's how much you're making in the 10th year. So that does come into play, but you're adding that to the 9th year, the 8th year, and so on. So I am going to use a series here. So my initial amount, my first term, is 51,000. And my common ratio, or my R, I need to do, when it's a percent, I do need to include that 1. So the 1.02 is going to be my R. Okay? So just keep that in mind. When you're doing a percent, you have to add it to 1. Okay? The reason why is if you don't, it's only going to add the 2%, not the entire salary. Okay, so let's plug in here. So I need to find S to the 10th year. So I'm going to take my 51,000, and I'm just looking at the formula on the first page, minus 51,000 times 1.02 to the power of 10 all over 1 minus 1.02. And so what the number you get is your salary added over the course of 10 years. And you should get $558,435.77. That to me makes a little bit more sense as far as what it's asking. Exercise 6 says Maria places $500 at the beginning of each year into an account that earns 5% interest compounded annually. Maria would like to determine how much money is in her account after she has made her $500 deposit at the beginning of the 11th year. This amount would not get any interest. Okay, so they want to know the total amount over the course of the 11 years. So it's also a series. My first term is going to be 500. My R is the 5%. Okay. But remember, because it's a percent, I'm going to do 1.05. I change it to a decimal. I move the decimal back twice, but it needs the 1 there. And then we're going to do it 11 years. So that is my N. So I'm finding S of 11. And I'm just following the formula as I've been doing. To the power of 11 all over 1 minus 1.05. And you should get $7,103.39. All right, I'm going to go back up to exercise 3 now, just because I love to go out of order. But the reason why I'm going to do exercise 3 last is because it's done differently. And since this is new, if I did this in the beginning, I think it would have been very confusing. So they're giving us a geometric series. They're saying, hey, this is a geometric series. Show the calculations that lead to your final answer. So if I were to plug into the geometric series, I do not know what term this is. I might be able to figure it out, but if it's like the 30th term, it's going to take you a long time and you don't really, you could easily make a mistake. So I don't know what n is. I do know my initial amount is 6. And then my common ratio, well, let me see here. How am I getting from 6 to 12? I'm adding 6 or I'm multiplying by 2. How do I get from 12 to 24? I'm multiplying by 2. Now, don't be confused because you see an addition sign there. That's because we're adding them together. We want the summation. But if I listed them out in terms, you would have to multiply them by 2. So my R is 2. And I don't know my n, and then I'm going to do 1 minus 2 on the bottom. All right. Now, if they want to know what the sum is, I do have to know what the n is. I can't calculate that sum if I don't know how many terms there are. So the question is, how do we find out how many terms there are? Well, I think I am going to use a geometric series equation just to help me figure out what that n is. So, a little refresher, that formula, again, you don't have to have it memorized, but it's good if you know it. So this is a geometric sequence, excuse me if I said series, this is a geometric sequence. So what I'm going to do is I know everything except for the n. So I'm going to use my 768 here because I want to figure out which term it is. My first term is 6, my R is 2, and I'm going to do n minus 1. A little bit of a tricky thing here. I'm solving for n, it's an exponent. I gotta use a log. Yikes. Okay, so in order to do that, my base needs to be alone, so I'm gonna divide both sides by 6. When I do that, I get 128 equals 2 to the n minus 1. Now, I'm sure you all recall that when we put something in log form, the way that we always did it was when the answer was on the right. So I'm just going to switch that around. For some of us, a handful of us, I would make an L, or technically a G. That just means that's the order I'm going to put it in when I put it in log form. So I hit the 2 first. So I'm going to do log base 2. I hit the 128 second, and then the last thing I hit with that funky looking G or L was n minus 1. All right. Now my n is not alone, so I'm going to add 1 to both sides. Now from here, you can put it in your calculator, but be careful. That 1 does not make that 128 a 129. It's tacked on to the end, okay? And when you put that in your calculator, you should get 8. If you are not getting 8 when you put that in your calculator, you need to chat me privately within, my office hours or a reasonable time, and we got to figure it out, okay? Now, I know my N. Now I can go back to the series that I already wrote in the beginning, and I'm going to put an 8 there. And now I'm going to put this whole crazy thing in my calculator, this whole thing here. And when you do that, you should get 1530. If you're not getting that, again, I want you to message me right away, because if you don't and it gets away from you, you're going to have a really hard time with the homework.